Okay, so in 8.2, number 6c, I would like to inverse Laplace transform s plus 9 over s squared plus 4s plus 5 times s squared minus 4s plus 13. So I would think to myself, aha, I should probably use partial fraction decomposition. Right? So let me scrap the fact that I was inverse Laplace transforming this for a minute and just look at this thing. So first things first, I need to aim at something that I can actually inverse Laplace transform. You guys see that? Like, we could try to partial fraction decompose this just as it stands, but I should probably try to partial fraction decompose it into something that I know I can partial fraction, or that I know I can inverse Laplace transform. Because otherwise I'll have a whole bunch of algebra.
So we want to make sure we don't make it like too basic, is what you're saying? Like if we could factor down even simpler, don't necessarily do that because it might be an inverse Laplace?
No, okay, so let's think about factoring this down. So, to look at this part, you want to know, is this an irreducible quadratic, or is it something I can factor and maybe reduce? Right?
It's pretty factorable.
Factors into...
I'd say like s plus 2. So
If it was 5 and 4, then you...
Yeah, you're like, okay, so I need two numbers that multiply to 5 and add to 4, right?
Yeah.
So, two numbers multiply to 5, add to 4 feels like 1 and 5, right? Well, except you have to subtract one of them. So you need a negative sign here.
Which you don't have.
Which I don't have. Another way you can check is you can think about what's b squared minus 4ac. Yeah, in this case, b squared minus 4ac would be 16 minus 4 times 5 times 1. Negative. This is irreducible quadratic. In other words, this thing, when you think about it as a parabola.
Damn, that's really weird.
Damn, that's really, yes, that's really a way to check. Right, checking for factorability across the real numbers is just like, yo dude, does it have x-intercepts or not? That thing doesn't have any x-intercepts because the discriminant, right, the thing under the square root, the quadratic formula, is negative. It's got complex zeros, but not real ones. Same thing for this guy.
Can we? No. It looks like it wants to be a perfect square.
13.
Yeah, and it looks like it wants to be a perfect square. That's a really good observation too.
Yeah.
So, this thing looks a lot like it wants to be s squared plus 4s plus 4, right?
Because that's
Plus
how I
1?
looked at it.
And the other one looks.
And this other one looks like it wants to be s squared minus 4s.
Oh, plus 4 plus 9.
Plus 4 plus 9.
Yeah.
Okay, so I know these guys are irreducible quadratics, right? So one thing I could try is I could go, alright, I'm going to factor that into as plus b over the first thing, s squared plus 4s plus 5, plus cs plus d, and maybe ds plus e, how about that? Over the second one, s squared minus 4s plus 13. Okay, like, I could totally do it this way. At the end here, you'd have to do a little bit of arithmetic and kind of algebraic rearrangement, because you don't know how to inverse Laplace transform b over s squared plus 4s plus 5. But you do know how to inverse Laplace transform a number over s squared minus, sorry, this one's s squared plus 2, s plus 2 quantity squared plus 1. You know how to inverse Laplace transform that thing. You guys see that? So there's a little bit of like, it's a good idea to aim at, and the thing you want to aim at is the bottoms are going to look like s plus 2 quantity squared plus 1, right? And s minus 2 quantity squared plus 9.
So we can actually always do that if they're quadratic. We just might end up with a disgusting one, some terrifying number added to it at the end. But like any quadratic, you can complete the square and have something left over.
Oh yeah, you can always complete the square, right? So if it's irreducible quadratic, you can always like start completing the square. And yeah, this number might be horrible. Just like top of your head, when could you inverse Laplace transform this easily?
Just separate them, right?
When there's a number on the top,
Or an S.
or when there's a
S plus
s plus 2. Not just an s, but an s plus 2.
Does it have to match the coefficient?
Yeah, it's got to match this guy. So, instead of guessing as plus b and then dorking around with it later, may as well guess a times s plus 2 plus b. Okay, see that? It's like, that thing will know how to inverse Laplace transform, and that thing will know how to inverse Laplace transform. One will be a cosine, the other one will be a sine. On the other one, what do I want to guess on top?
ds plus
Oops, definitely not a.
d
D,
minus s minus 2?
s minus 2, plus e,
Why'd you skip C? Just,
because it looks like a paren.
oh, okay.
And if you were really clever with yourself, you'd look in the Laplace transform table and you'd be like, okay, 9's 3 squared, right?
Yeah.
And 1 is 1 squared.
And so you're going to know how to inverse Laplace transform this not when there's any old number on top, but when there's a 3 up there. So you might put a 3 on your e. Like if you're going to be really
You can just do
frickin'
that?
slick.
Yeah, can you just put
Yeah,
it?
e's an arbitrary constant, right?
Oh,
You're going to
true.
solve for it anyway.
Or
You guys see that? Like that's the reason I'm getting away with having an s plus 2 in here.
because it's constant.
Right, because I'm kind of like fiddling with my arbitrary constants. These arbitrary constants and these ones would be different. I'm just like preloading a little algebra into this so I don't have to screw with it later.
So we can just take B as 1 and E as 3?
No, but it might be a good idea to put a 3 on here.
Oh, okay.
Okay, so
That's
that's,
going to change when you're adding up your.
yeah, I'm not going to do that, but it might be a good idea. Like if you've preloaded a few of these,
So
you'll figure out
we
how
put
it
the
works.
3 there to help it fit the form of an inverse Laplace, right?
Yeah.
Okay.
Yeah. So it's essentially the same reason I put an s plus 2 and an s minus 2.
Mm-hmm.
Okay, so now on.
Now we just solve for A and B.
Yeah, so now I need to solve for A, B, and D, and E, right? So here's what I know. I know that A times s plus 2 plus B all times
S minus 2 squared.
Plus 3.
s minus 2 squared plus 3 squared, right?
Equals s plus 1.
Plus
Plus D times s minus 2 plus E times s plus 2 squared plus 1 is supposed to equal
S plus
S
9.
plus
s plus 9. Blank, right? Now you need to get some equations out of here, right? You guys kind of with me?
Yeah.
Okay, so I'm going to do this the cheaty way. Just because. You could do this a bunch of different ways. I don't really care which ones you use. I'm going to multiply the bottoms back out. This one was
Squared plus 4 is plus 5. Right, I'm sorry, S squared minus 4 is plus 3.
s squared minus 4s plus 13. Don't multiply that back out yourself. You already factored it, right? Like you did that complete the square problem already. Use that to your advantage. The other one was s squared plus 4s plus 5. And now you need to multiply some stuff together, right? So I need a all told in here I have an AS plus 2A plus B. And all told in here, I have a DS minus 2D plus 3, or plus E, rather. All the multiplying ever will happen now, right? So you get AS cubed minus 4AS squared plus 13AS, and then 2AS squared minus 8AS plus 26A. You guys see I'm kind of carefully organizing. And BS squared minus 4BS plus 13B. So that's my first ones. And then this guy is a DS cubed plus 4DS squared plus, oops, that's 5DS. And then the middle guy is minus,
2ds squared.
my attention span got too short, minus 8DS. Oh no,
2ds squared.
what am I
Is
doing?
that 5ds?
That's this and that. That's minus 2DS squared. That's this times this. Then minus 8DS. Then minus 10D. Then I have an ES squared. I have a 4ES. And a 5E. So this jump plus this jump equals S plus 9.
Yeah, so out of that you get A plus D equals 0.
Okay, so out of that you get A plus D, wait, let's not be dumb,
A equals negative D.
A plus 0B plus 0, oh no, plus D plus 0E equals 0. That's A plus D is 0. Then I have, what else?
Minus 2a.
I have this whole thing about S squareds, right? You see that? So this one is minus 2A
Plus e.
plus B. And this one is 2D plus E. And then I'm dropping the S squareds, right? So I have minus 2A plus B plus 2Ds plus an E is, how many S squareds you got on the other side?
0.
0. Is with me? Then on my S's, all told here, I have 5A minus 4B. And over here, I have
3d plus 4.
negative 3D plus 4E. Nice. And so those go in here as minus 2A, nope, 5A minus 4B
Minus 3D.
minus 3D plus 4E is,
1.
you got one S on the other side. Nice. And then your last one is 26 A's plus 13 B's. It's supposed to be a 13, not BB's. And then minus 10D plus 5E is 9. Somebody cram that in a calculator and ref it for me.
What, you don't want us to solve this by hand?
No, hell no. This thing. So you're going to need to augment, right? So you're going to need to make a 4 by 5. matrix and dump all this crap in there. And then when you ref it, what are you going to get?
Values for A, B, D, and E.
Yeah, you're going to get, somebody got it? So your matrix is going to look, so ref of this crap is going to give you a matrix that looks like 1, 0, 0, 0, augmented by,
Well, I think that, yeah. For some reason I get all zeros, I don't know what happened.
you get all zeros down here.
Yeah, I don't know
That's not good.
So just the
I
solution
got
that way.
1, 0, 0, 0, then I got 1/8,
why. Yeah, that's good.
then I got 0, 1, 0, 0, 1/4, then I got 0, 0, 1, 0, minus 1/8, 0, 0, 0, 1, 1/4.
That's much better.
Yeah,
I was really concerned when it was all zeros.
yeah, I don't know why I did it. I probably entered them twice.
Probably a minus sign or a typo or something. Okay, so I got this as my ref, which says what? What is a ref?
Yeah, where is it? I guess I missed
It's
it.
under matrix math.
Okay.
So if you go hit second matrix and then hit over, you'll get to math, and then it's like choice B. Depends on the calculator. That's reduced row echelon form. That's doing all the Gaussian elimination steps to get to basically a solution. So this says A is an eighth, B is a quarter, C is a minus an eighth, and D is a quarter. So I can just go shove those in over here. So, thanks to y'all being industrious, I got this. So quarter minus an eighth plus a quarter.
What exactly are you putting into the R ref again?
Oh, this whole thing turned into a matrix. So, thinking about this, I'm looking at this whole thing and thinking that 1A, no B's, 1D, no E's, augmented by 0.
So this is the 4 by 5. And you have like 0, 1, or 0, 0, 1, and 9 in your matrix at the end.
And then next row is going to be minus 2, 1, 2, 1, 0. Basically, I'm just pulling the coefficients off, right? That's all a matrix is. All a matrix is a convenient way to write down a system of equations where instead of writing down a whole bunch of variables, you just use where it is in the box to represent the number. I say that's all a matrix is, but that's not all. That's all a matrix is in that calculator.
Are we gonna ever get RREF forms where we have like a 1 and then a 0 and then a 1 in the top row and we have like 1A plus 1B equals 1/8, or is that not how it would work?
That's not going to happen in this case, because if that does happen, that meant you had a dependent set of equations, which means that your partial fraction decomposition failed, which it wouldn't if you set it up right. So that's going to be either a typo in entering the matrix, or maybe an error in setting up your partial fraction decomposition.
Alright.
Once I'm here, what do? So like once I found those things, I partial fraction decomposed this sucker, then what?
You need to turn the quarters into ones.
Yeah, like massage it a little bit first. So first things first, make that into an eighth times s plus 2 over s plus 2 squared plus 1. Right? Like that's that first component. And then you have plus a quarter times 1 over s plus 2 squared plus 1. Okay, see that? Like, first thing, split 2 pieces, pull the constants down in the front. Second thing, split into 2 pieces. So you got your minus an eighth, your s minus 2 over s minus 2 quantity squared plus 3 squared. Okay, and then you got your plus a quarter.
1 over that chance.
Yeah, and on this one you want to put a 3 on top. So in order to get a 3 on top, I need to put a 3 on the bottom out here.
Yeah, that's
So I'm going to switch that to a 12th instead of a quarter. And that's an s minus 2 squared plus 3 squared. And then if I was to inverse Laplace transform this whole thing, like put my fancy L's back on it here. I'd be inverse Laplace transforming this piece plus inverse Laplace transforming this piece. I'm going to put this one in there. So I should have put the other two in there. Right, my L's should really be in here. They're really skinny. What am I using to do that?
linearity.
Yeah, I'm basically just exploiting linearity.
Is that 1/12 just from multiplying by 3 over 3?
Yep. Yeah, identically. Nice. And then this first thing is an 1/8 for sure. There's an e to the
Minus 2t
minus 2t and a
cosine of t.
cosine of t. Really, that's cosine of 1t, right? And then your next thing, you got a quarter, and that's
E to the minus 2t
e to the minus 2t,
sine of t.
and that's a sine of t. And your next one's a minus an 1/8, and that thing's e to the positive 2t, and then a
Cosine of t.
cosine, and this one's a 3t because of that 3.
Plus a 12.
And then I have plus a 12, and an e to the 2t because of the shift, and a sine of 3t. Stick the landing, 10 points.
Check down.
Checked out. Easy? No. Not even close.
I'm still getting hung up by the RF. I do RF and I just have two.
Not
C's.
RF, not REF, but RR.
Yeah.
You got that?
REF, and then I just have two parentheses I can put numbers in.
You put your matrix.
Oh,
in-
you gotta put the
your
matrix in
again, and then you go to
Oh.
name on your matrix, and you just.
Yeah, sorry, on the calculator this should look something
Okay.
like this.
That, yeah.
And you gotta go get that thing under the matrix button, you can't put 2 square brackets in the letter A, it gets really confused.
Find that, and then hit matrix again and go find it.
I was putting the 10100 in there and it kept saying wrong data type.
Yeah, cause it needs to be a matrix, so you need to
Okay.
go into the matrix button, edit a matrix,
Make,
put this crap in it,
alright.
then go out of the matrix button, go back in, get the ref, go out,
Go back
Okay.
in.
go get the matrix's name, put it in there, and then hit enter.
That makes a little more
So you're
sense.
saying you put that in there, so it'd be like a plus b is equal to 0 would be one of them?
No, it's just
Just the coefficient. So 1, 0, 1, 0,
Okay.
0. Minus 2, 1, 2, 1, 0. 5, minus 4, minus 3, 4, 1. And just make sure that these are arranged in the right order. Right, if you've got your A's and your B's in the wrong spots, don't put them in the matrix that way, put them in the right spots before you put them in the matrix. It uses the columns to keep track of the A coefficients, and B coefficients, and D coefficients, and E coefficients. So if you put them in the wrong spot, you're actually switching the coefficients.
Okay, and that'd be a 4 by 5 then?
And this would be 4 rows and 5 columns.
Okay, I got a question on, when we're doing these, the inverse Laplace transforms at the very end, right there. The second term, why is that the same, like form as the first term if it's not s plus 2 on the top, since it's just a 1?
It's a sign.
So in the Laplace
Yeah,
table,
'cause I'm looking at the table, it's, I don't know, I'm getting confused.
so I think there's this. I think this is maybe the thing that would help. If you transform if you Laplace transform cosine of t,
Mm-hmm.
you get s over s plus 1. S over s squared plus 1.
Oh, yeah, but
And
that's
if
1
you
squared,
Laplace
right, technically?
transform, yeah, that's 1 squared.
Yeah,
1 squared.
Just to fit the form, yeah.
And then if you Laplace transform sine of t,
Yeah, omega over s squared plus.
yeah, so you'd get 1 over s squared plus 1
Oh,
squared.
okay, that's where the sign came from.
Yeah, so the sines have just a number on top, and the cosines have this same piece.
And you're gonna
So
wanna-
that's technically our s, right? The
Yeah,
S-
that's like
S plus
playing the
2
role
is
of
our
s.
And then,
And then I
Laplace
shifted
transform of
because of the
1.
e.
okay.
So if you go look for the rule for e,
Well, I'm looking at the rule and
times
it's
a
got,
function.
yeah, it's got the e to the, lambda t times cosine omega t. That's what that is.
Yeah, so that'd be,
S minus lambda
Yeah.
over s minus lambda squared plus omega squared.
Yeah.
Technically.
so this is minus minus 2.